In the 17th century, warships were constructed by hand. It all started with the keel, the backbone of the ship.
Constructing a warship was extremely complicated. You had to create a hull, starting with a keel, onto which you join wooden frames, like the ribs connected to one's sternum.
These ribs or frames gave the hull its shape. It was much less slender than that of the galley, because the builders were looking less for the best movement through the water than the efficient distribution of the artillery's significant weight. In order to erect an impenetrable barrier, the distance between each frame was smaller than the width of a cannonball.
Onto this wooden structure, they nailed the planking on the outside, so very long planks of wood which were placed along the hull from the keel to the upper deck. Inside, there was more strengthening, an inner skin, if you like, called the ceiling, so it was reinforced by planks of wood on the inside.
Frames, planking and ceiling formed a hull, which could be up to a metre thick. That's why it was called the wall. This wall was pierced for the gun ports. They were arranged at an equal distance, 2.4 metres apart. And so as not to weaken the hull, they were arranged in a checkerboard pattern. The position of the gun ports was of crucial importance, as shown by the tragic fate of the Wasser. Disaster struck during the Swedish ship's maiden voyage on the 10th of August, 1628.
The boat was very unstable. The gun ports were too low down, and the water very rapidly flooded into the hull, making it sink very quickly.
That day, the 1,000 sailors on board lost their lives in the port of Stockholm. The sinking of the Wasser highlighted the importance of the height of battery.
This is the distance between the waterline and the bottom of the lower battery gun port. There must be a certain distance, or else the ship will take on water through the gun ports and will end up sinking. So this height of battery can't be too small, but it can't be too big either, or the stability of the ship will be affected. It will lack stability. It won't have a good attitude in the water.
After a year in the shipyard, the hull was finished and launched. The final stage could begin, the fitting out of the ship. This wasn't about positioning the artillery, but rather installing the masts, sails, and rigging. The masts reached 30 meters high, the equivalent of a 10-story building. To help with their installation, the shipbuilders used a sort of crane called a masting machine.
They had what was called a masting machine, which was about 70 meters tall. It was made up of big masts tied together with ropes, which were made to lift very heavy loads and to install the lower sections of the masts in the ships in the vertical position. Then they added the upper sections of the masts, which were ringed with iron, and then they could add all the sails.
The surface area of the sails determined the ship's speed, a decisive element during battles at sea.
As ships became bigger and heavier, as they carried more artillery, they needed more efficient sails, because the sails were the engine. So they increased the surface area to make the ship go faster. You could divide the sails into two groups. The big rectangular or trapezium-shaped sails were mainly used for propulsion, for speed, and the smaller triangular or square sails were used more for maneuvering the ship.
In full sail, these heavily armed ships could reach 9 knots, or 17 kilometers per hour. That was 30% faster than galleys. It took about 100 craftsmen a year and a half to build these Lords of the Sea. Each ship was unique because the master shipbuilders guarded their trade secrets jealously.
The extraordinary thing about these wooden ships was that the builders handed down their technical expertise through 6 or 7 generations.
The designers of the ships stuck to the tried and tested methods. It's like recipes in cooking. Once you have the right balance, you don't change it. There's the know-how, the knack, all of that.
Whilst the recipes most often produced efficient ships, they sometimes made ships that were incapable of putting to sea. Given their cost, the Navy couldn't afford a failure like the Wasser.
The number of people it took between the master shipbuilders, the shipbuilders, shipwrights, the cannon manufacturers, the foundry workers, the sailmakers, everything you need on a ship, from planking to hemp, cannons and armaments. It was quite extraordinary.
A ship cost £1 million in the late 18th century, which was equivalent to 300 kilograms of gold.
For the time, this extraordinary cost forced France to draw up construction standards that would guarantee the excellence of ships. Arsenals like Toulon, Brest, Rochefort or Lorient played an essential role. They developed new technical solutions and trained the best shipbuilders using extremely detailed models.
These big models, usually 1 to 10 scale, were almost a kind of simulator. You stood around them. You were there to learn. You were there also to see the effect of the wind on the sails. They were instructing the master shipbuilders. So they were a real 3D training school.
In 1765, France founded the School of Maritime Engineering. It trained the future engineers who would replace the old shipbuilders. These men of science used the new mathematics and insisted on drawings. It was the birth of modern naval architecture.
In the 18th century, times had changed. Certain inefficient ships had been abandoned for good, and the 74-gun ship of the line had been perfected. It was the battleship par excellence.
Its name was the Téméraire. It was the first warship built according to a naval architectural plan. The plan was the work of 2 men, Jean-Charles de Borda and Jacques-Noël Sanet.
Borda was the academic, the mathematician, the scholar, and Sanet was the highly skilled and competent engineer who made his career following the training route of the time as a shipbuilding engineer.
Together, they optimized the 74-gun ship of the line, conceived 40 years earlier. They found the best compromise between firepower and nautical qualities.
It was the result of a lot of research to obtain a ship that was capable of functioning as well as possible at sea while fulfilling its military role as an artillery platform.
The ship's dimensions were impressive. 57 meters long, 15 meters wide. Its tallest mast was 85 meters high.
When you imagine a ship moored at a quay level with a person, with its banks of sails, it was pretty impressive. If you placed a 74-gun ship of the line with all its sails unfurled in front of the Arc de Triomphe, the arch would be completely hidden, completely invisible.
It weighed 2,950 tons. This giant was powered by more than 40 sails, with a total surface area of 2,600 square meters, or 6 basketball courts. This powerful propulsion allowed it to reach the unheard-of speed of 11 knots, or 20 kilometers per hour. The ship also had exceptional maneuverability, a crucial advantage in battle.
These nautical qualities were desirable because in battle, changing tack was a very complex operation. Tacking took half an hour of manoeuvres, assuming that the enemy wasn't firing at you from all directions. So the desire for maneuverability was essential in terms of war.
The ship could change tack in just 15 minutes. That was half the time of its opponents. This prowess was made possible by the addition of one element on the mizzen sail, located at the stern of the ship, the boom.
Gradually, this sail was perfected. The bottom of the sail was attached to a piece of wood called a boom, which kept the sail more rigid. And that was great, because it meant you could trim the sail very accurately and adjust it by a few degrees, more or less.
Fast and manoeuvrable, the ship was powerfully armed. Its 74 guns were arranged in 2 batteries. In the lower battery, there were 28 36-pounder guns. In the upper battery, 30 18-pounders, and on the upper deck, 16 8-pounders. In the hold, it carried 4,400 cannonballs and 22 tons of gunpowder, enough to last 6 months. This ship was a formidable artillery platform. Sané-and-Borda's ship of the line was the centerpiece of the French Navy.
The ship was built according to blueprints which standardized the model. That meant they could develop construction according to pre-established, standardized models, with a ship that would be identical.
In 1 century, around 100 ships were produced in the shipyards. This success inspired foreign navies which sought to copy them.
In the 18th century, industrial espionage was rife. There were British engineers who tried to come to Toulon to spy, and also to Rochefort. This espionage also happened when an enemy ship was captured, so technical knowledge and know-how circulated widely.